What's up, guys? It's Hayden Devs here, or Hey Devs. I think that's the name I'm gonna go with. But today we're gonna do a little bit of LeetCode. I figured it'd be beneficial for me to do at least one LeetCode problem a day and explain my thought process. Today I think we're gonna do two. I recorded this morning, and my girlfriend was asleep, so I wasn't really talking that loud. You can't really hear me at all. So I'm gonna try to record it again. And the two problems we did was the contains duplicate and valid anagram. And we did these we did these problems in Java. So I'll just go ahead and get started. So I won't tell you that. So we'll just go ahead and search up contains duplicate. Here we go. We'll open that new tab, and then the other one is the valid anagram. A little reason for me wanting to do these is because I haven't programmed in Java in so long. Java's been my favorite so far. I just seem to understand object-oriented the paradigm object-oriented paradigm pretty well. And so we're going to go ahead and delete all of this. Oh, well, I didn't mean to do that, so we'll just redo that, and then we will redo that. Okay, we'll start with the contains duplicate. This one's not too bad. It's a decently simple solution. So given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So for example, 1 is 1, 2, 3, 1. Since there's two ones, there's a duplicate, and we don't want that, so we'd return true. And then for this one, 1, 2, 3, 4, we would return false since there's no duplicates. The simplest way, I think, to do this would be to create a set. Create a hash set, and then we'll add every element into the set. And then we will, if it contains the element we're about to add, we will break out and go ahead and return true. And if it goes through the entire loop, then we will return false. I'll kind of explain what I mean more. So we're going to have a set of integers, since we get an array of integers. And we're going to call this just num set. I'll set this equal to a new hash set. And capitalize integers. Alright, and then we need to call the constructor. Okay, so now we have our num set, and we'll want to loop over each num. So for int num and nums, we'll want to excuse me, I'm so sorry. So we need to check if the set contains the num we're looking at. So this for loop will give us each number inside of the nums array, one at a time for each number. It's a little bit more concise than doing the for each loop. This is not the for each. The normal for loop with the index. It just goes ahead and gives you every single element that would be in the array without having to index them individually. So we'll see if numsets.contains num. And if it contains the number, then we would want to if it already retains it, we want to return. I think it's true if it contains, yeah. And then else we'll want to add numset dot, let's add, and then we'll add the num into the num set. And then if it breaks out of this, we want to return false. Let's go ahead and run this and see what it does. Error, in the file without parsing. Oh, I deleted this. Semicolon. Okay, so all test cases will approve. We'll go ahead and submit this and see if we get Nice. So 14 milliseconds. We can see our other submissions. 13, 14. I wonder what's the difference in my two submissions. If num set dot contains none, return true. To me, this looks exactly the same. Maybe it just... Okay, I'm not going to worry too much about it. But the basics is you want to create a set, because in the set data structure, you cannot have you can't have duplicates of elements in the array. So you can go ahead and add each number, and then you can see if it already contains that number for each iteration loop. And the reason we check that throughout the array of numbers, you can imagine the array of numbers is 100 elements long, and then the first two elements are 2 ones. Okay, so it would only take 2 loops to figure out that there is a duplicate, and it will break out and go ahead and return true. Versus if you didn't do that, you could say, this is my original solution without looking at the solutions tab. And my original solution was just for each number, go ahead and add it into the set, and then at the end you would check the size of the set versus the size of the array, and then that would if they weren't equal to each other, then you knew that they were duplicates, because you can't have more than one element, one of each type of element inside of the array, inside of the set, because each set has to be distinct, and you can't have duplicates in there. So this just kind of, I don't know if it's short-circuiting, but it would go ahead and break out of the function earlier versus checking all 100 or 1,000 elements inside of the array. I thought this one was pretty interesting and not too bad. If you have any questions about it, let me know, of course. So the next problem I did was the valid anagram. We're going off of the LeetCode roadmap, of course. And I'm thinking about doing 1 or 2 problems a day off of this thing, posting it online. So I think I've already done the 2 someone. I think I've done 5 or 6 problems on LeetCode, but I've done no other problems other than that. So we're just going to go ahead and redo the valid anagram one as well. So this one's not too bad. This is the problem 242 valid anagram. Given 2 strings S and T, return true if T is an anagram of S and false otherwise. So an anagram would have the same letters and the same amount of letters. So both of these have 2 A's or 3 A's and 1 N, 1 G, 1 R, and 1 M. So my original solution was to create a map. Well, if I can type, was to create a map of characters and integers for each of the strings. So I would do smap is equal to new hash map of character and integers. And then I created a control structure. So we wanted to loop, well, the first thing you can check, of course, is they cannot be an anagram if the strings are not the same length. So you can check if the s dot length is equal to t dot length. Well, we can check if they're not equal to. And if they're not equal to each other, then you can go ahead and return false. This gives you a short and simple check. In a lot of problems, the simple things to check for that would make it false, for this one, it's a Boolean statement. For most Boolean functions, if there's something simple that will make it false, you want to go ahead and check that first before you do all your logic, and then check it at the end. So if we went ahead and added everything into the maps and then checked if they were equal, we would get false eventually, but this just goes ahead and breaks out of the function earlier, kind of like us checking for the contains in the last problem. So you want to check that first, and this will allow you to see if there even possibly can be anagrams of each other, because they have to be the same length of each other. So then from here, I went ahead and created two maps, one for each of the strings, and then we looped over each element in the array. We got the char at each point. We went ahead and checked if the char was already in the map. So for the first example, the anagram, for the first loop, we would get the A. If the A was already in the was in the map, then we went ahead. In this case, A is not in the map yet, so we would see if it contains A. And since it doesn't contain A, we would go ahead and add A as a new key and give it the integer value of 1. So that is counting that A has 1 value. And then the next element would be N. So our map would have A1 and N1. Okay, and then the third value of A, once it gets to that, it would see if it already contains A as a key value. And in this example, since it already does have A, we would go ahead and get the value that A stores. So in this case, it would be 1. We would take the 1, we would add 1 to it, because now we don't have 1A anymore, we've counted 2 A's so far, and we would update the map value to 2. So in the third loop of this first example for S, we would have A equals A, and then it's grouped with 2, and then N is the key value for 1. So it was just kind of keeping up count of how many letters we have of each. And at the end, I thought we could go ahead and compare each of them. Now, if you see in the submissions tab, it was 31 milliseconds, and the solution we saw from the solutions tab is 5 milliseconds. And I thought the solution that we saw, that I implemented later, is a fairly what's it called? A fairly creative solution that I didn't think of. So what they did was create an int array of, and they called it frequency. Okay. And we want that to equal a new int array of 26. So each array index is equal to a character value. And another thing you might be thinking, what if there's a capital? It says right here that S and T consist of only lowercase English letters, so we won't have to worry about changing any character to lowercase before checking it or anything like that. Which could be troublesome, because then we would just have to add an extra statement to change every character to lowercase to be sure to check it and make sure that they can become anagrams of each other. But in this case, they used a frequency array and of size 26, and then each index corresponded to that letter in the alphabet. So 0 is A, 2 is B, so on and so forth, all the way to Z. And they checked each. They did a for statement. For string for int I is equal to 0, then I is less than s dot length, and then I plus. And they went ahead and got the frequency of and they checked the index of s dot char at I. So they got the character at the current size. So say if it was 0, we would get the A. And they subtracted the character value of A from it, which I thought was very clever to do this. Because if you didn't know, characters are stored in Unicode, and they all have a value associated, like an integer value associated with them. And when A is printed on a screen, it is checked against the Unicode value. Like I think A is 50 something. I'm going to go ahead and check this Unicode values. Yeah. So you can search online and find a chart like this. Yeah, so it says right here, so A is 65, capital A, and then lowercase a is 61, or 97 actually, not 61, in the Unicode. So it would say 91 minus 91 in this situation and give you the index value of 0. And then if it was B, it would give you 1, giving you the index value of 1. And then so for each value that's an S, we would want to increment it. Okay. And then you would check the same for each loop of the T value. So we would check the char at I for T, and we would subtract A as well to get the index of the value. And so what this is it, once it goes through the entire list, if they have the same amount of letters and they're the same letters in each and they're an anagram of each other, the array should have 0 at each value. So we would need to check that. So for int, we'll do another int loop, or we could do int, we just want to check the number inside the frequency array. So for each number in the frequency array, not equals, we'll do the colon. We need to check if the num is equal to 0, or we need to check if it's not equal to 0. Because if it's not equal to 0, then we know that they are not the same, and they're not anagrams of each other. So we need to return false. And then if it makes it through both these loops and gets to the end, then we can go ahead and return true, because we know they're both anagrams of each other. And I thought this was fairly interesting just because of the char at minus A giving you the index value of the array that corresponds to each letter. So that was a fairly interesting solution. And the plus plus and minus minus, I thought that was also very, very intriguing compared to my double map solution that took 51 seconds. That's nice. So this has an overall time complexity of O of n. The reason of that is because the int num of frequency is a standard 26 no matter what. So you know it is running 26 times. So that's a constant time, and we don't really count constant time in the O of n problems. This is a single check, so this is also a constant time. So the only loop we would be interested in is the for loop. So for int I equals 0, I is less than s dot length. So the real time complexity comes in however long s is, which I know s is less than 26, but for the sake of O of n complexity, it is the same size as the size of our strings. And we can go ahead, and we saw the test cases came back true. We can go ahead and submit this again and see what we get. Yeah, so 6 milliseconds. I wonder why all my solutions are 1 millisecond slower than they were earlier. As you can see, I did these 10 hours ago, but the video was not very well made or produced. But this one took 31 milliseconds. And if we take a look at it right here on the left, we can see, kind of analyze the time complexity of this one. So the time complexity is also O of n. So for int I equals 0, s is dot length. I is less than s dot length. So we want to, it's going to loop for every element in the string, giving us the size of the string is the ultimate determining, or ultimate is the one that ultimately determines the time our program takes. Where mine lacks compared to the other one is the overhead used when we create 2 map objects, and it takes more storage as well. So we have 2 map objects in storage. For each loop, we check, we get the character at char at. That's not very different than the char at here. So we're getting char ats, the char at I for both of the values. You can see t char and s char. But then I think where we lose most of the time is in these if statements that is nested inside of the loop. So for each value, we have to check if it contains the key. So it does a little search. It searches inside the map and see if it contains the key. And I think that's another O of n. So it might be n squared at this point. So n for the length, and then n squared for checking the contains key at each value. And then it puts it into the char array, it gets the value. So it's just real slow compared to the other one. And I think it's just the overhead of using a map and checking the contains and the gets. The puts don't really matter too often. It does do a little check to see if the schar is already in the map. I thought these were fairly, this solution was very clever with the frequency. You can go ahead and see the different solutions in here. And I suggest you try to give this problem a shot and see if you can get any farther than I did without looking at the solutions. Anyways, that was Hey Devs for, I think I'm going to call this series doing a LeetCode problem every day until I get a job. And I'll just kind of walk through my thought process of each problem. I'm not really the best teacher, but I feel like it would be beneficial maybe to someone, and it'll be beneficial to me for sure to get these LeetCode problems done. Anyways, I hope you enjoyed the video. Have a blessed day and good afternoon, and I hope you have a good one.